Hello everyone, my name is Kanti Velamuri. I'm a technical account manager here at AWS. And today this recording is going to help you go through the workshop that will show how you can deploy an agent end to end from development to production in AWS Bedrock AgentCore managed service. I think most of you would have already got the workshop links in your personal emails or in your official emails that you have used to register for the BeSA program. If you click on that link, it should bring you to this page where you may, in my case, I have already logged into the workshop, but you may have to log in by giving your email ID and giving the OTP that will come and everything. And once you are logged into the workshop studio and click on the link that is needed, that was provided for this event, you will be seeing this page where you have to accept the terms and conditions and click on joint event. And once you have logged into the event, you should see a page very similar to this one. The name of the workshop is Getting Started with Amazon Bedrock AgentCore. There are about 9 labs in this workshop, as you can see here. And as you make progress towards each lab, you will be improving your capabilities of your agent and then successfully able to develop to production. Show how you have done that one. Before getting or moving forward, I would recommend that you log out of every other AWS account you're already logged in. Strictly make sure that you are only logged into the workshop lab environment. That way, your usage, AWS usage, and everything is within this lab environment and it's not outside anywhere. Also, few things from logistics perspective. So the lab environment AWS console is accessible by clicking this link. So you can either click here or you can copy it and open it in a new browser. Like that. Okay. Once you are in the AWS console, make sure you are in the US East 1 region. That's where you can also see here that it shows as US East 1. If in this workshop, there is no necessity for the CLI credentials, but if you are curious, this is how you can access the CLI credentials for this AWS account. And then we will be using throughout the workshop, we'll be using VS Code server, the Visual Studio Code server. And in order to access that code editor, this is the URL that is there. And you should go there and open up your code server. Again, all this information will be on the very first page on your event page when you are logged into the event. By any chance, if you have clicked in here, you will not have the code server URL. Always go back here to get the code server URL. Now, this lab environment is provisioned with some of the prerequisites or some of the code or some Lambda functions that were already needed for this lab to do a demo and everything. And they are already provisioned and available in your lab environment here in this one. As we make progress to those sections, you will see them or look into them. One important thing to note, do not upload any of your personal information or anything as such, or do not try to use any services outside of this workshop requirement, because this is a very restricted lab environment and most of the services and permissions are completely locked down. So even if you attempt, you will not have enough IAM roles or permissions to do other things. This lab environment will be very restricted towards what you can do in the workshop environment. That said, we can proceed with starting the workshop. At a very high level, you will see that this workshop has two different setup. One is the AWS event setup and one is the self-paced setup. So in this case, you should follow the instructions of AWS event setup because what has been provisioned to you, and when you click on the link, this is where you are coming in. The self-paced setup is more for if you want to set up everything in your personal or professional AWS account, or you want to use your own local laptop and all those things, then you will be using this self-paced setup. We highly recommend that you try to use the AWS event setup so that it is a little bit easier for you to follow through the workshop, as well as you can focus mainly on the agent development and agent deployment and understanding Amazon Bedrock Agent Core service instead of trying to do the basic installs and other things. That would be the recommendation. One thing I want to highlight is this workshop is using Amazon Bedrock Agent Core managed service, but the concept of deploying or developing the agent from production to deploying into production and maintaining it, considering different aspects of agent anatomy, that is the concept that I would recommend that you grasp from this workshop, regardless of what technique tech stack or regardless of what platform that you're using on the backend. You can always deploy the same agent in an EKS. You can always deploy this through Lambdas. You can do other ways as well. So rather than trying to focus on the Bedrock Agent Core service part, I would say concentrate on the concept of how the agent development can be improved, what different aspects are needed when it comes to production deployment, and what all things have to be implemented. That's what we will focus on. So a quick rundown of the workshop here, as you can see. We will be building an agent prototype, then we'll add memory to the agent so it remembers what it has been doing or what it has to do. And then we'll scale the agent deployment to an enterprise deployment level. We will secure the agent and we'll also add some observability around it. Then we will evaluate the quality of the agent responses. Finally, we'll try to build a UI interface to interact with the agent. And then you want to make sure your agent is following the rules, has certain policies and things. And lastly, we want to make sure we are optimizing the quality of your agent. So these are all the things at a high level we'll be going through in the lab. Let's start with the lab itself. Let's go into the AWS event setup page. Here, as I said earlier, you were able to see that I had that same page. This is where I have checked in and agreed terms and conditions. And make sure, as I said, you should be in the US East 1 region. That's where you are in, confirm on that part. And once you are there, like I said, open the code editor. That should open the IDE for you. We'll be doing everything through the CLI or through the IDE today, all the lab, most of the lab. Even though I'll open the console and show for a few things to you, all the implementation, everything goes through the CLI and the IDE. Now, once inside you are in the IDE, click on these three dots and go to View and then go for Terminal. That's how you will be able to open the terminal. You can ignore these banners over here and go to the file, go to the view, go to the terminal and open up the terminal. And you should be in this path. You should be in the workshop path. That's where you should be. And when you try to type anything, you will get a prompt like this, or like when you try to paste anything or do anything, you'll get a prompt like this. Just allow for now so that you can always copy paste from the workshop page to the editor without any problems. So let's try that one. Let's simply do few tests. Let's check what our AWS ID is. What is the agent core CLI? There is an agent core CLI, very similar to AWS CLI. That will help us to connect with the Bedrock managed service agent core and do our tasks and everything. We will also need a Node.js as well as we will also need a AWS CDK. So all these are already pre-provisioned as part of the workshop environment. We are just going to quickly test if everything is good here. So as I said, once I tried to copy paste, I got this prompt. I'm gonna allow everything. That will allow me to copy paste easily going forward. Okay. Once everything looks good, all the versions are good. The Node.js is above 22 version, and then I have everything that I need. In case if you have any issues of something is not found or something like that, you can follow these instructions to do that. On top of it, when we are provisioning this environment, you are getting Claude along with that one. So if you want for any reason you want to use Claude, you can always do that one. With that, it can be a helpful companion for you and help with any issues, or if you are not able to complete the lab or having any trouble, you can always look into that one. Sometimes in some of the workshops here, there may be a situation where we want you to copy something into a file and that file is not visible or something like that. So for example, let's say it asked you to update this index.html file as per the instructions, but you don't see what it is. Make sure to you click the file like this. That's when the drop will come down, like you will be able to see the whole thing. Okay. So don't think that your page has not loaded or there are any issues as that. Just make sure that you click here and that's how you're able to see it. Okay. We have completed everything on this page. We validated everything. Everything is good. Now let's move on to the, we are not doing the self-paced setup. So let's move on to the next page here. All right. So in this lab one, we will be building a customer support agent that can answer questions about products, look up any written policies, and it will be able to search the web for any troubleshooting issues the customer has reported. For example, my smartwatch is not starting or my smartphone is having some problem. It's going to look up into the web and then give you some instructions on how to troubleshoot and fix that. Uh, so we are going to build the agent or develop the agent in this lab. For that, before that, let's start a AgentCore project. In order to start the AgentCore project, you can always do it like AgentCore create in an interactive mode, and then it'll ask for information like what is the project name, what is the agent name, what is the agent type, like that. It can keep prompting you and you can keep answering. That's one way you can do that. Or you can use the CLI command directly by copying from here. We have commands for both that are compatible for both Windows and Linux platforms. In this case, our VS Code is in the Linux platform. So I'm going to use the Linux command here. So I'm going to create a agent name called as customer support. It's going to use the Strands framework. I'm sure you might have experience with other frameworks like LangGraph or LangCrew and all. And also I'm going to use for model provider Bedrock. As of now, I'm not creating any memory or anything for my agent. So this is my agent core project. So you should see something like this. The agent has been successfully created and all. So I would like to quickly walk through some of the files here. So the customer support agent, the agent core related configuration or agent core related implementation and everything will be in this folder. Whereas under the app folder is where all your agent related Python code and everything will be there. The main important entry point of your agent is going to be the main.py here. And as I have mentioned earlier, we are using Strands framework for developing this agent and everything. And as we are trying to, as I mentioned, this customer support agent is going to connect to the web in order to look for any troubleshooting or anything as such. So we are going to use exa.ai MCP server to do the web searches and any type of crawling or anything that is needed to help with the troubleshooting skills. And under the model folder is where we have the load.py, and this is where I'm defining which model this particular agent should be using. So that's one of the important files here as well. With that, let's start, This is a simple agents.md, and this has a very basic information and everything over here. So with that, let's go back, and you should be, whatever I suggested, that's whatever I showed earlier. They are explaining that over here. You can take your time and read through that workshop accordingly. So now you have to actually go into the folder where we have the agent and everything. And as I mentioned, the main files, you'll be working mostly with the main.py, the load.py, where there is model configured. And then, oh, I totally here under agent core, the important configuration file is the agentcore.json. So this has each section here. As we make progress through the lab, you will see each section getting populated. These are all different modules or features of agent code that are available today. And as we make progress, as we will be using some of these modules, and you can see them getting updated with all the configurations and all. Other than that, this AWS targets.json file is where you'll specify which region you want your agent to be deployed and which AWS account you want your agent to be deployed, etc. So this is very specific to the module configuration, and this is very specific to your target, like which AWS account and which whatever it is. So these are the two important files when it comes to the agent code folder. All right. With that, if you're curious what other files are there, how is that implementation and all, you can definitely expand this and read more. So when the main.py got created, like the default one, it came up with a very simple tool that will help to make a sum of two numbers, a plus b. But that's not what it is. We are building a customer support agent here. So we are going to replace the content of that main.py file with all of this. So we are specifying some return policies. We are also adding some product information. And then we are going to use Python code like tools. And then we are going to call those information for us to do any work that is needed. And this is where we are going to create the agent using AgentCore. App.entryPoint is the main functionality or main code snippet that is needed for your agent to be AgentCore compatible. So let me take all of this here and then replace it with what I have got from the workshop page. Then I'm going to save all of this information here. So my agent is now updated. Just in case, if you want to ensure your copy paste is successful, go to the terminal and simply type the commands that are there over, and you should see everything should be parsing fine. There is no copy paste error or anything as such. Once that is completed, you want to update this more if this workshop to use Claude Sonnet 4.6 because that's how this workshop is more supported. And as earlier I mentioned you, under model folder load.py is where you have Claude Sonnet 4.5. We are now going to update this to Claude Sonnet 4.6. Okay, we are going to take this and then save. So pretty much the workshop is going to go in this mode only. You will be reading through what is specified here, understand why we are doing this step or how this step is going to help us with real world scenario and everything. And then you'll be taking the code snippets, copying them, updating them, and follow through the lab. This is how the structure of this workshop is going to be. That's why, as I said, you'll be heavily using the IDE, heavily using the CLI. Very limited console use is going to be there. Okay, I just verified that whatever copy we made into the model load.py file has parsed and has no issues as such. So at this point, this is how your agent architecture is. User is going to ask a question to the customer support agent. This is trans symbol, by the way. So this is a trans agent. And then this support agent has two tools. One is to get the return policy and one is to get the product information, which you have added in the main.py, as you can see here. Get return policy and then get product info. This is what your agent is capable of doing. Additionally, it's going to connect to the MCP client for XAI web app search. So this is what your agent can do. And we have specified which LLM module it should use. And for the model provider, it's going to connect to the Amazon Bedrock. This is the current structure of your agent. As we make progress in the labs, you will see this structure keep expanding. We will be adding more features, more functionalities, and all of those will make sense as you move forward. Now we can locally test your agent before even deploying to anywhere, just how you do your regular code local testing. This is going to be very similar. One thing to note though, the web-based inspector here is if you are doing a self-paced environment here. Remember, instead of doing the AWS event, if you are doing self-paced, that's when you'll be able to do the instructions from web-based inspector. Otherwise, if you are sticking with the AWS event, then please follow the steps from the terminal based. Because this ID, this code server has limitation, you cannot actually open a web-based or anything as such. This is a lab environment and that web-based setup is restricted here. So the simple agent core command that will help us to test our agent locally is agent core dev. To keep it more easy for you to see what I'm doing, I'll clear up the console and well, that is all you get is a status okay here and you are inside the agent now. You are now connected or locally testing the agent. You can simply test your agent by saying, asking this prompt, what is the return policy for electronics? So it gave you an answer. It should match with what you have specified here. Electronics, 30-day window, original packaging must be there. Items must be in their original packaging and full refund to the original payment method. That's the return policy you have specified and that's what exactly what it has written for you. If you are interested, you can try some more prompts here like this and verify and understand what's going on and how this happened and all. Other than that, if you want to test that MCP, the web MCP, you can ask for troubleshooting steps. As I mentioned, for troubleshooting, it's going to use the MCP. So it's going to go and connect for that one and bring up its results from the web. So as you can see, it's saying that it is searching for it. So that's how you are able to connect to it. If you want, you can also do like multi-tool query, meaning like you want to understand the smartwatch and want to do like a written policy around that. Then what it is going to do is it's going to get the product info of this product ID that you have mentioned, and then it's also going to get the written policy. So it's going to invoke both the tools. You can test that prompt as well. So as you can see, it got the product details, it got the return policy, both of them. We are all good here. We are all set. Let's just do Control C as specified here. You can just close the tab or do Control C and get out of your agent. Your agent is working locally well. I think you are confident enough to deploy into production. So you want your agent to run in the cloud, right? Or into an actual environment. So all you have to do is agent code deploy. So far, the different agent core commands you have experienced is agent core create, which helped you to create the project and everything for you to start. After agent core create, you have implemented something like you used something like agent core dev that helped you to locally test. And now we are going to use another agent core CLI command, which is deploy. That successfully deployed our agent. Now we can do an agent core status and you can see that the ARN has been generated and your agent is active. Same thing, we can go to the AWS console, look for service, Agent Core, Bedrock Agent Core. That's what we will go in. And if you go to the runtime, this is where you have your agent deployed. See, this is where you have your agent deployed, and it has one endpoint, and we are at the version 1, the first version of this one. You can test your agent if you are interested in. Whatever output you got in that CLI before, very similar output you'll be getting here. And that's how you'll be able to test this agent. So this is where the agent has been deployed. And from the CLI itself, if you want to talk to the agent, you can say agent, let me clear this, agent core invoke. So after deploy command, we did status command, and now we are invoking the agent, asking what it can do for us. So it came up with an answer saying that this is what I'll be able to do for you. Okay. Yeah, as I was mentioning earlier, you can go to the AWS console and you can notice. So now from the previous lab to now, how your environment has changed is everything is the same, pretty much the same. It's just that all this part, the customer support part, the agent deployment and everything is now inside Agent Core runtime. So earlier, the architecture was it's in your local environment. Now, all of that section has moved into the Agent Core run. With that, let's move on to the next lab of the workshop. So you have an agent that is working great. And now if you want to interact with your agent, but you don't, it doesn't have the memory of who you are. And every time when you reach out to it, you have to keep explaining, saying that, hey, I'm Kanti and I need to do this one. This is why I have reached out to you. And then that session got closed. Again, you had a question on that one. Again, you have to go back to the agent and like, I'm Kanti, this is what I'm expecting. This is what I want you to help with. So instead of having customer do multiple times the same thing, we have something called as memory. And Agent Core has two memories, a short-term memory and a long-term memory. And there are certain strategies with which you can build these memories for long-term memory. And the three strategies are the semantic, summarization, and user preference. In this lab examples, we are going to show semantic and the summarization examples. You can read through what is the difference between session persistence versus agent core memory. We have some tests coming up in the upcoming labs where you will be seeing the difference between both of them and all. But yeah, this is where we are. And so let's go ahead and do agent core add memory. Now, what will that command do? Let's see. So earlier I was telling you, right? Every section is going to get updated. It's going to have different things. Right now you see the memory section is blank here in the agent code JSON file under customer support. Now, once I execute this command, what will happen is you will now see that the memories have been updated. And the two strategies, the semantic and the summarization strategies, have been added. What happens is when you execute deploy command later on, that JSON file or the configuration will be taken and will be deployed into your AWS account. So earlier when you can see that a shared memory has been added. Now you can cat or look at the agent code JSON, which I had showed to you earlier. Now let's integrate our memory into the agent code. So by executing this one, see in your agent, earlier you only had MCP client, model, skills, and then you had the main.py. We'll come to skills in a little bit, but yeah, Now a different folder got created, memory, and it has a new session.py file. This is where we are going to add the next part of the code. Open the session.py file. And what happens is this module creates a memory session manager that connects to your agent. It configures two retrieval spaces, and it's going to use both summaries and semantic strategies. And the memory shared memory ID variable is automatically injected when there is agent core runtime. So let's take that in code and we can put it here. You can take your time to read through this code, understand what it is about and all, but at a high level, it is the functionality of it is to add the memory. Now, in the actual agent main code itself, you have to make sure that it is using the memory session manager, and it is also using your memory session ID when it is trying to do here. So it's going to pull the context and everything from that memory session ID and use it. So let's take this updated code, go back to your workshop, go to main.py, and replace everything with the updated code. So that's how you will be able to incorporate memory into your. Now, another step we need to do is we have to add a customer header. We need to add a customer header, which is Amazon Bedrock AgentCore user ID, into the allow list for your runtime to work. So going back to the JSON file here, in the runtime, we should add the Amazon Bedrock. Make sure that you are keeping the spaces alignment without any issues. Okay. Do not skip this step. It's a very important step for us to take care of. Now, with the updated configurations, we are ready to deploy the agent again. While we are waiting there, what happens is everything will be deployed and the version of your agent will be updated. So that changes the architecture now this way. So you have now added agent core memory component versus the previous. So in the runtime, you have the agent and everything deployed. And in your, the agent is now communicating to the agent core memory for session and everything. The memory creation takes a bit of longer time here. Okay, it has been deployed. We now have a memory, shared memory and everything set up. If you go back to the console and do a quick refresh, you will see that we are at the version 2 now. And if you go to the memory, we have now memory created for the customer support. Now, let's try to test this memory part. Okay. What we are going to do is we are going to create a session A ID, and then we are going to invoke the agent with that session A ID. And we are going to pass the header, the user ID as Sarah. And Sarah is giving her preference here, saying that she prefers email updates so that the agent will always remember that in the future. So copy this here and let me clear this a bit so it's easy for you to see. So you can see that now agent is going to remember the preference of Sarah and it's also pulling the information and everything. You can see that I'm going to generate a separate UID or a new session ID, but I'm going to invoke with that session ID, still pass the username as Sarah. And the agent should still recognize you because of the user ID information that I'm passing, because that is there in the memory right now. So let's execute that. Since we asked it to sleep for 2 minutes, we have to wait and see how it's going to look like. So the strategy wise, my name is Sarah. I prefer email updates. That's a semantic strategy. But the full conversation, like what happened, where it is going to answer you. That's going to be the summarization strategy. So as we were doing earlier, you can see that it waited for a few minutes, but it still recognized me as Sarah because I passed the user ID. And it did tell what my recent purchase was and how it can help me and everything. So that's how the agent core memory will work. If you are interested, you can wait for this whole agent core VM to be gone as well. Agent core uses micro VMs on the backend. The runtime, you can go idle enough on the runtime, wait for the VM to be recycled, another VM will be provisioned, and you can then use that new ID and everything to do the testing. That's an additional test if you're interested to do. But that successfully you were able to test the long-term memory and everything for this one. Now let's proceed. Now, you have a working agent. It is deployed in a runtime environment that is applicable for production. You have memory added to your agent. Now you want to scale your agent. Scale your agent to connect to other existing tools in your environment. So for example, there may be a lot of business logic and functionalities developed in Lambda today in your environments, and there may be other existing API calls, or there may be other MCP servers or some other sort of templates, etc., that your agent needs to use to complete the business workflow or to complete the functionality that you're looking for. So Agent Core Gateway can help you achieve all of that. What it can do is it has multiple varieties of target types like Lambda functions, API gateways, model targets, MCP targets, other integration providers, etc. And what will happen or how your architecture is going to change is for tool 1 and 2, that is getting the return policy, product information, you'll be using the agent code itself. Whereas for web search and other crawling and other things, you are using the XIMCP. But you can also call one of your existing Lambda functions using Agent Core Gateway for warranty. We are going to check the warranty of your product, which is an existing Lambda function. We are going to add this. Meanwhile, the other functionality is pretty much going to remain the same. So let's, in your lab environment, you should already have this warranty check Lambda function deployed. For your understanding, you can go through the code source of this particular Lambda. Okay. And then if you want, you can take a moment and see. So it's going to be very similar. It's going to have the warranties of all of these products. Okay. Now let's retrieve the ARN of this Lambda and save it in a variable here in our terminal, as we are going to use that to configure the gateway. And remember earlier in the agent code.json, we have runtimes and memories. We don't have anything for gateways. So this section is what we are going to update now before deploying. Okay. Now let's create a tool schema. So the Lambda functions, how the agents understand instructions is natural language. That's what generative AI is about and all, right? But the Lambda function is simply a code with an input event and an output and everything. And it's not built in a way where natural language communication is possible. And that's the gap that the agent core gateway is going to bridge. It is going to wrap your Lambda behind an MCP compatible endpoint, and it will provide you the tool description and everything, how this tool is going to help the agent to achieve its functionalities. So let's go ahead and create a tool folder here. Let me minimize this. So, and that's where you got the tool. And now we have a JSON. In this JSON, we will define the warranty tool information in a natural language, as you can see here. So basically, you will have to check the product ID, check the warranty status, etc. We are defining the tool functionality, the warranty tool functionality in a natural language here. in a very descriptive field in any way. After everything is set, we will have to wire everything together. So obviously we are going to add the gateway. The name is going to be for the customer support runtime. We are going to add the gateway, my gateway. And then we are going to add gateway target is going to be the Lambda function, the warranty check Lambda function. So let's go ahead and make those changes here. And that should update our agentcore.json. And now you can see that this section has been updated. So this is the Lambda function that we are going to add as a target for this gateway. Once all that is set, we will have to obviously update the MCP client to use the gateway MCP client as well. So we are going to take, this code and go into the MCP client and go to the client.py and going to replace this code with this one. So this is where we are calling the gateway MCP as well, along with the EXA MCP. So let's take this and save it. Okay. Lastly, we have to update our agent code, the main.py file itself, to add the get gateway MCP client. So let's take this additional here. So as you can see, we are adding the get gateway MCP client. We are also importing that along with the web MCP that we have. So let's take this, go to the main.py, and let's take and replace all the code with this one successfully. And make sure that you save your changes. And once all is set, all the wiring is completed, let's go ahead and successfully deploy this version or this updated version of the agent. Okay, now if you go back to the agent core and go to the runtime, you can see that we are at the version 3 where everything has been updated and created. Perfect. Now let's test the gateway tool. So we are going to request the warranty details of a particular product. So let me ask that question to the agent. And there you go. I got the warranty duration and everything of the product 003. And that information is here in the Lambda function. Warranty month of 6 months, etc. So that's successfully how we were able to make a existing Lambda MCP call. Let's see. So unfortunately, the warranty of the laptop has been expired. If you want to test with an active warranty, you can go back and do this, and it will help you to test with the active warranty. So this is the flow. AgentCore invoke will go to the runtime. Runtime will go to the gateway and get the URL. The gateway will talk to the MCP client. The MCP will route to the warranty check Lambda, and the Lambda will execute and return the result. And then the agent synthesizes the response. That's successfully the request flow that we have implemented now. And so the warranty is fully valid. That completes lab 3. Now let's move on to the lab 4. Now everything is great. Our agent is deployed. It remembers the users. It can call remote tools. But by default, we are now interacting with agent by logging in with my AWS credentials. That's how we are communicating. So that means it's using AWS credentials or IAM, AWS IAM with the permission to invoke it. And so the URL or anything is not open to anyone. It doesn't have any end user identity or anything as such. Also, what or how this agent is behaving, what is the observability for this agent, where are the traces, metrics, logs, how is the agent code runtime happening, all those things are not there. On top of it, when it comes to the enterprise environment, you don't want to have individual AWS users logging into your agent. You want a user-based authentication, like you want your customers to be able to access your agent and everything. And for that, the Agent Core gateway and runtime both support JWT-based authentications. In this example, we'll be using Cognito to demonstrate, but you can connect to any OIDC compatible JWT based authentication and secure your environments. So let's start. Let's verify the deployment status of our agent now. Okay. So we have a runtime deployed, we have a memory deployed, and we have a gateway deployed, and that has one target that is added to it. That's the status right now, which matches here. So in order to test the session continuity and isolation, meaning like you pass a session ID with each invocation and the runtime keeps the conversation context. Each session runs in its own micro VM. So once that session is closed, that micro VM is lost. And the single user stays on the same execution environment, which is the maximum duration. There is a one-to-one mapping basically. To see the difference between session persistence and the agent code memory clearly, you will use a brand new user ID called Alex, and then we will do this lab accordingly. Let's use a fresh user ID called as Alex. Okay. And we are going to go with session one. Okay. So let's come here. Let's do this. So it provided the information related to the mechanical keyboard and everything. Okay. Now in the same session, using session one itself, I'm going to ask it again, like, what did I just buy? And it has to respond back to me saying that it's the mechanical keyboard. Okay. Now the agent remembers the Alex and everything. So this is basically session persistence. The running conversation is kept, and then we are using the user ID and all. And this is not agent core memory. It's all based on session one. Now let's start a new session, which is session two, for the same user. And immediately before memory aggregation has had time to process. At this time, the agent will not know who Alex is. So let's say I'll clear this one and I'll provide this. See, it clearly said that it is not able to access my order history or anything. Even though I gave the user ID as Alex, since I came to a different session, you can see that it was not able to retrieve the information. Now let's demonstrate what happens when user does have stored memories. So remember for Sarah, we have stored the memory. So let's go to that session, create a new session, session 3, but give Sarah. And Sarah has memory from our previous lab, if you remember. So I think I copied it wrong. Let me copy it properly here and add it again. See, it gave my profile preferences, which is email updates, and it also mentioned about the laptop and the smartwatch for Sarah. So this is the difference between session persistence versus the memory of the agent itself. So that's how you are checking the scope and mechanism and everything of everything. Now we can explore the observability aspect of this one. So Agent Core has logs. So let's simply just do Agent Core traces, and it's going to bring up the last 10 traces here. Now you can, if you want to download the most recent trace to the trace to a JSON file, you can do that one. Let me take this command here and replace the trace ID with the trace from here. Trace ID from here. And then execute that. Ignore this banner for now. And I got a trace.json file. And when I open the trace.json file, it clearly tells me what has happened, what is the timestamp, what are the attributes, what went through, and everything. So that's the detailed log information of the agent core service. You can also you view the logs from agent core CLI. So simply do agent core logs. If you want, you can stop the stream and you can look for anything specific like log level that has error log in the last 1 hour. I don't have anything as errors there. So I'm good there. But if you want to see anything for queries that came related to warranty, I can always grab that one. See, I have a bunch of them because for Sarah, we have been asking for warranty and everything. So that's how you will be able to look at logs, troubleshoot, and do everything. Other than that, you can also go into the CloudWatch console in the browser in your AWS console. And under that one, we have something like GenAI observability and Bedrock AgentCore. And this is where you will see your agent related. So this is the customer support agent, which we have been playing around with. This is where you'll find all the information and observability related to that one. So you can go to sessions, you can go to traces, and then you can look at each one of them in this like sessions and traces and see how the calls has happened, what's going on, what are the error rates, etc. like that. Now, the next interesting section is the securing your runtime with the Cognito authentication, which I spoke about earlier. So by default, it uses IAM authorization, but we are going to now change that to set up Cognito. The prerequisites cloud formation stack, like whatever is needed for this lab environment, some of it has been already provisioned and that configuration has been stored in the parameter store, SSM parameter store. So we just need to pull that information and then update our configuration and everything and use that to deploy the agent again. So this is simple AWS CLI commands here that we are doing where we are going to SSM and getting the existing Cognito related parameters. So let's go ahead and execute that here. Let me clear this terminal for quick um, visibility. And voila, we got our details that are already provisioned in this environment. Now we need to update the agent code.json with this information related to Bedrock authorization and everything. Okay, so let's go ahead and take this whole runtime section as is. Go back to the agent code.json and then go to the runtimes, pick up the runtimes and make sure the spaces and everything are good. Okay, that didn't copy properly. Let me just undo that and see if there is for me an easier way to do this. All right, I will have to update this section with authorization. Add a trailing comma here because this is JSON. And then update this part. Okay. And let's replace these Cognito values from here. So let's take this one and copy it over here. And then the client ID value and web client ID value. So let's take the client ID value. and the web client ID value. Then make sure you update and save the file successfully. So once all that is replaced, so for the agent to update the agent with this authentication and everything, we will have to install the PyJWT package to support it. So let's quickly run that one over here. Okay, that's successfully how you can do that. And then let's go to the main.py and add an extract user ID tool that's gonna get the user information um, from the bearer tokens, JWT, bearer token and everything. So we are gonna update with this functionality, all right? And we are also going to import the JWT package. So let's go ahead, go to the main.py file and replace everything with this and make sure that you save the file. And that successfully updates to this one. Now let's make sure that the JSON file changes we made are fine and there are no problems as such there. Okay. Because it was a manual editing, we want to make sure the syntax is good and all. So that looks great. Yeah, I'm just in case, if you have any spacing issues or anything, those validations, if they don't get validated, you'll not be able to deploy the agent. So now I'm gonna redeploy the agent by adding the Cognito into the picture. Okay, let's go ahead and refresh here. We are now in the version 4. And let's try to create the workshop user. There you go. The user has been updated. Lastly, we are going to authenticate with that user and get a token out of it. And we got the JWT token successfully. Now that we have the token, we are going to invoke the agent using that token, session 3, and we are going to pass the token information. I'm successfully able to invoke the agent without any problems and was able to retrieve the return policy. Now, without passing the token, you can try accessing just for confirmation purposes and see you got a is configured for custom AJWT, and that since the token is not available, it's not able to provide you the policy. So with that, we have so far secured our AgentCore runtime. Now we can do the same way by securing the gateway too. So that way, whoever calls the gateway and whoever calls from the gateway, everything is scoped and easily maintained. So let's go here and remove whatever gateway configuration we have. So let's go back to the AgentCore. And you can see that now the AgentCore gateways is nothing. Now let's come here and again add the agent gateway by giving the Cognito information in place. So that's how it's going to be there. And we are going to make sure the warranty check lambda is added as the target. So let's get the details of that lambda here. And lastly, add the target. So add gateway target. So once we do all of that, see now the AgentCore JSON file has the gateway information updated with the Lambda function, with the Cognito URLs, everything in place. So that's how it is. Okay, now let's go ahead and open the MCP client and change the environment variable. So the AgentCore gateway is now going to be AgentCore secure gateway. So if you go to the MCP client dot thing, currently you can see that the gateway URL is AgentCore gateway my gateway URL. But what we are updating here is my gateway is secure. We are changing the name of the gateway. So we need to make sure that part is updated. So let's go back to the client.py and let's do that change and make sure that it is gateway secure URL now and then save it. Okay, all the wiring and everything has been in place. Obviously, we will have to update our client main.py of the agent file to pass the authorization header to your gateway. That way, the gateway will go and talk to the MCP for the warranty information. So what we are going to do here in the code, that means how is it going to change? Is here we are going to pass the authorization header to the gateway. That way, the gateway knows that this is a secured authorized user that is coming to me, and I can provide him with the information that he's looking for. So let's go to the main.py. Let's update all of the code and then save it. Perfect. So all the wiring is in place. Everything is good. Let's make sure the JSON changes have not broken the configuration in any way. Everything looks great. Then successfully, let's deploy the agent. Once the agent is successfully deployed, we are now going to test the warranty using the secured gateway. So successfully, the gateway has been updated. You can now go to the gateways and see we now have a secure gateway that is deployed. And the target for that is the Lambda. So that's how we have everything. Let's test the secured gateway by giving the bearer token and everything. So let me make this more readable. We are passing the token and we are checking for the warranty of product 001. It should return us a value. See, I got the warranty information and everything without any issues. You can wait for a few minutes and go back to the CloudWatch console and see those invocations, how those are there any errors and things like that. In case while you are working, if your token gets expired and you want to re-get your token or something, just execute this token command. It will automatically give you a new token and you'll be able to make progress accordingly. So now successfully, how did the architecture change after this lab? Everything is now deployed into AgentCore runtime. And then we are having agent code memory to retrieve the user information and sessions and everything. We are making a call to agent core identity that is helping with the agent core identity. We are also having one tool going through agent core gateway, which has the AWS Lambda as the target. And this agent core gateway is also authenticating via agent core identity. And the agent itself is also authenticating via agent core identity. On top of it, we are now sending all the traces and everything to the agent core observability. So with that, 1, 2, 3, 4, 5 different components or 5 different features of agent core has been implemented or deployed so far with this lab. All right, that's good. That concludes the lab 4. Let's move on to the next lab. Okay, let's proceed with lab 5 now. So now our agent is deployed, it is secured, and it has observability and everything in place. But how do you know if it is actually good at giving the answers that it is supposed to give to the customers? Are their problems clearly getting solved? What is the quality of the agent. So for that, we have something called as AgentCore evaluations, and we have evaluation monitors we can enable, and it will give some measurements or metrics in terms of goal success rate, the correctness of the answer, and then the tool selection accuracy. All those things will be there. We have about 13 built-in evaluators, and more will be coming as we make progress. So all those evaluators will help in covering the helpfulness, faithfulness, harmfulness, coherence, consciousness, other things. So let's go ahead and create the evaluation. As always, in the agent called JSON, you can see that the evaluators or the online evaluate configurations, all these are currently none. So we are now going to add that functionality to our agent. So we are adding a quality monitor, and can now see that the online eval configs have been updated. All right, let's go ahead. In this case, we are using the sampling rate of 100, which means for every response, for every interaction is getting evaluated. But in production environment, typically it is recommended for 10 to 20% to balance the cost and the coverage, because cost goes very high if you do evaluation for each and every interaction. Try to find a ground, common ground where that is possible for the sampling rate and everything. Okay, so let's go ahead and deploy this agent with evaluation enabled. Okay, if you want, you can do an agent core status command, and that will show you that a runtime has been deployed and it's ready. There is a shared memory that is deployed with the strategies of semantic and summarization. We have a gateway that is secured and deployed with one target, which is the Lambda. And then we have a online evaluator configuration also deployed. And we have 3 evaluators and 100% sampling that is enabled. So that's what it is. Now let's go ahead and to generate some test interactions. Before that, you know that now everything has to be a secure communication. So let's make sure that our token is successfully good. Everything is clean, and we have a new Cognito token for ourselves. Now let's generate some varied interactions with the agent. So for example, some questions like, what can you tell me about the smartwatch? What's the price and warranty? I bought some headphones. What's the return policy? What's the warranty status of something? I want to return something. What do that look like? And all those things. So I've generated a couple of interactions here, and all those interactions should now have evaluations in place. So basically, we are making sure the quality of these answers is good and everything. That means it's properly referring to your KBs and all, and it's returning the proper answers. Okay. So with all of this in place, generally we'll get evaluation scores. 80 to 100% means it's an excellent interpretation. We just have to make sure we monitor the agent and maintain it. If it is 60 to 80%, there is a good interpretation, but there is scope for improving. We have to review wherever we have low scoring sessions and see what went wrong and try to fix that. And then for below 60%, definitely the interpretation is not good, and we have to improve our prompt, or we have to do other things to make sure that the agent is giving right answers. So let's go to the CloudWatch console, to the Bedrock AgentCore, and here we will go under evaluations. That's where, we'll go to the evaluation tab, and the dashboard should show what is this information. Typically, this information takes some time, so you will have to wait, just because we just generated those things. So while we are waiting here This will definitely take more than 15 to 20 minutes. So I would recommend that we proceed ahead with the workshop while we wait for these evaluations to show up for us here. All right. If you want, you can also do an on-demand evaluation instead of just having interactions with agent and having that agent interactions, evaluations coming into the CloudWatch and everything. You can also do like an on-demand evaluation like this. Excuse me, you have to call the evaluator command. And we want the built-in goal success rate and the built-in correctness. Your output should look something like this. So it had about like 11 sessions and the success rate was around something like this. These numbers may vary depending on how your agent responded because your agent connects to LLM and LLM is non-deterministic. So every agent, every response, you will not exactly see these numbers. There will be some variation, but the output should look very similar to like this. So you can also look into the history and determine, like, get a summary of what the session's evaluation results have been and everything. You can also do logs, like you can look at the evaluation logs, and that will give you a very detailed verbose JSON of how the LLM judge scored each of your interaction and how everything looks, what's the accuracy and all. So you can also pause your evaluations. You can resume your evaluations if you want. Like for example, for the next few sessions, you don't want it. So with that, the architecture now changes along with observability. We have now configured online evaluation, which is agent core evaluations. So we have 1, 2, 3, 4, 5, and 6 different components or modules of agent core that we have applied. Again, in the beginning of the lab, I mentioned that it is not a learning agent core. It is about applying the concept to how you can deploy your environment from development to production. So these are all things, regardless of you are using agent code or not, we recommend that you do for your agent when you're planning to deploy it into the production. Looks like I have some issue there. Anyways, feel free to run through this lab and it will give you a good understanding of the evaluations and everything. All right. Now let's proceed on building the customer interface. So you have been talking to your agent completely on CLI basis so far, but that, you don't, that's not how the user preference will be. They would like to have a UI or something. So we are going to build a Flask application. User opens the front end and then the Flask will authenticate using the Cognito. There will be a HTML page and user will have a chat box in which he'll go and talk. And the chat box uses the browser calls the Agent Core REST API using the bearer header, and the Agent Core runtime will validate the JWT and process the request. And then the agent uses the tools and we'll get the answer. So let's install the Flask related packages here. Once that is set, let's create the front-end template application and everything that we need to do. So now we got the front-end folder here, as you have seen. Okay. Now let's go ahead and get the code for the frontend.py. You can always take your time and go through this code, but it's gonna be very easily understandable. Uh, let's save this one. So for production, there is a observation that is given here. Make sure you read that and you understand that you don't hard code any credentials or anything as such. Then let's create the UI in the index.html file. So let's go here, go to the templates and go to index.html And then let's update the HTML code for the UI chat interface. Let's minimize this so it's easy for us. Finally, for the front-end application to be set up and everything, let's update the Cognito pool or information accordingly so that we have required access. So let's come here, run this, and update everything. So in case you are curious, user password auth, whatever we have used, that same CLI, everything that we used in the lab 4, we are making sure that it is enabled for web path as well, not just the CLI path. That's all that is. So now let's start the Flask application. So you you will get a pop-up like this, allow that to be opened in the browser. And you can see that we are authenticated as the workshop user. That's what it is, the Cognito call is. Okay. Once you open it, you can simply start chatting with it. Execute some of this and test the interface. Now, if you want to test the session part of it, see, it says that it doesn't have. Now, let's say my name is Alex. And again, let's ask it, what's my name? See, it says my name is Alex. Now, let's say we go to the new session and again ask it. It should fail. Only the long-term memory facts like preferences, etc. will be saved. So that completes lab 6. Now let's talk what else you can add to your agent. So consider a scenario where now you know your warranties, you know your refund policies and everything. You ask the agent to process a refund saying that I want a 10,000 refund without any governance. Right now, we did not define any policies or anything. We didn't say anything. So without any governance, the agent will simply happily comply and it's going to give you that refund. But that's not how you want it, right? You want to make sure that it doesn't do that kind of thing. So for that, you have to, let's open up a different, this is already running. So we need to do that one. In the other terminal, we are now going to run this part. Okay. And let's add the refund tool to the gateway. So come here and we have another refund lambda, workshop process refund. We are going to use that refund and add that to your lambdas. So under tool, along with warranty, now we have the refund schema. Okay. And if you open the refund schema JSON, as of now, there is nothing, but we are now going to define, similar to how we have defined the warranty.json, we are now going to define the refund.json as well in natural language. Then we will add this to the gateway. We are going to add this to the gateway. So currently, if you go to the agentcore.json, the gateway only has the warranty check as the target type. Now let's add the process refund also as another target. So this is another Lambda call that's going to happen. Let's take that and deploy. Finally, our evaluations have come back. You can see the success rate, the accuracy, as well as the correctness. We now have the values for that. And the session evaluations, what was the score on it? The trace evaluations, how was the score on it? The span evaluations, how was the score on it? So overall, you got your evaluation success and details and everything. Like I said, it will take some time, so we will have to wait. Okay. Now the agent has been updated again. Going to the runtime, we are at the version 6 of this one. And let's go ahead and um, request this part to the agent. Let's create a policy engine that will make sure that um, we have governance we can add. So let's go to agentcode.json. And if we go under policy engines, nothing is written right now. So we are going to add the policy engine now. And we are going to limit how these refunds can be given. So we are going to permit refunds under $100, and then we are going to permit the warranty checks. So let's get the gateway ARN here. And let's go ahead and add the policy. So there is a known bug in this module at this moment, and the application team is working on that one. So you can see in the policy engine here, the policy refund policy limit has been updated. We would also like to make sure that it adds the warranty check policy. So if you come here, you will see that the warranty check policy also has been updated. But while deploying, we noticed that there is a bug in this module little bit, which our service team is working on. So, but I'll still show you. And if you encounter that error, please just ignore and move forward at the moment. All right. Now, if you do agent core status, you can see that the agent runtime is deployed, memories are deployed, gateway is deployed. It has two targets now, warranty and refunds. It has evaluations deployed. It has policy engine deployed. And we have two different policies, the refund and warrant check policy. With that, if you go to the console, you will see we are at the version 7 of this one. Okay. I think it's the version 6. So now let's go and try to test our agent. So it says my refund has been processed successfully because it's under $100. So let's say I want to ask refund for 1, 2, 3, 4, 5 itself. Again, some of these answers and everything may not be exactly what you're looking for because LLMs are non-deterministic, so the behavior will be very different. Some of the things you see in the workshop, some of the things you see in the recording may not be the exact answers you will be getting as well. See here, it said that it is not able to process $500 refund for the order 1, 2, 3, 4, 5. Let's say I want to check the warranty of this product. It should be able to do that because in the policy engine, we have defined that this is what it can do. So it was able to check the warranty and get back to me. You can also write these policies if you want instead of code, like, specifying like this and all. You can do a natural language saying that for bit so and so, something like that, and that should work. As I said, we have a known bug here. So if you encounter this problem, please just ignore it. It's just that that's a known issue. The service team is working on the back end. You can simply take this part and incorporate it manually for now, but the expectation is in the future it should do it automatically. Okay, and let's save that one. And once that is saved, again with the latest generated policy, let's go ahead and deploy the agent. So what we are doing is we are forbidding any refunds if the reason is not defective. If the reason is defective, then only we process any refunds. That's what we are doing right now. So here in this prompt example, you can see that I mentioned explicitly that the item is defective, and here we are not specifying that. So that's why it should get denied. And with this lab, we have now added additional component, which is AgentCore policy. Let's wait for this deployment to be successful and completed. We will test some of these prompts and then move to the bonus one. All right, let's go ahead and ask the agent for this question. So we have now 3 policies deployed. So it said it has successfully processed that. And now let me ask for the agent to do this. It said, our return policy requires the items to be unused or defective. And since I did not mention that, it's not going to do that. So that's how you can control your agent or, provide guardrails to it. Now, what we are going to do here in this bonus section is, so we have a deterministic CDR policies. We are saying that if anything, refund under $100 permitted, or warranty checks. If there is warranty, then permit it, etc. We also added like a forbid policy and everything. But the tool input guardrail, so not a pre-model. So basically the customer support model sees the customer messages first and then it constructs the tool arguments. At the gateway boundary itself, let's say I'm passing any sensitive information like my email ID or something. I don't want that request to process at all, like go to the LLM at all, because you don't want your PI data going to the LLM, right? So we are going to put some blockers on sensitive information and everything like that. That's the lab, what we are going to do. So let's go ahead and pull our gateway ARN here. And now that we have that, let's go ahead and add the forbid when guardrails, sensitive information in the context input reason. If there is anything like email or so, we are now going to ignore that kind of request. So let's go ahead and add that. And now in your AgentCore JSON, you have one more policy, the block sensitive refund reasons. Okay. And now that you have that is updated and everything, let's go ahead and deploy the agent again. For this section to work, definitely your lab should be in US East 1. That's why in the beginning of the lab itself, I mentioned that you should make sure that your region is in US East 1. So here the prompt, if I think you will understand if I show the prompt. So the defective item is personalized with the wrong email address. Could you include that address in the refund reason so the support team knows that what was printed? So here, because the guardrails block emails, this particular thing should be blocked. That's the expectation that we have. Let the deployment complete. Okay, everything is deployed. So let's go ahead and ask the agent for this refund. Include the email address in the refund reason field. While I understand it may seem helpful, embedding this is that said, I'm happy to process the refund for defect item. So like I said, like you said, it likely the email bearing call is denied. The model may retry without the address. So it's non-deterministic behavior. So you cannot expect it, but it clearly mentioned that it cannot do email and things. So this one, it was successfully able to do it. That seems incorrect. So we need to provide a different order ID. Let's see. But you should get the gist what I'm trying to say here. So you can provide guardrails, you can adjust this, and uh, is it clearly said why it's not able to do the refund and everything. Anyways, so that's how it is, and this is the optional part. If you want, you can keep this policy. If you want, you can delete the policy, like a targeted delete is possible. You can simply say remove the policy, and it's going to update the JSON. And once the JSON is updated, you have to redeploy the agent. Yeah. So with that, we have looked at guarding the agent or adding guardrails to it, making sure the agent actions are controlled and have specific outcomes as much as possible, what we can do here. Now, you don't have any custom orchestration code. You don't have this main.py. You don't know how to write this main.py, or your expertise is not in that field or something like that. You can actually use something called as harness, agent core harness, and you can define your entire agent, like the model, the system prompt, and the tools and everything in one single CLI command. You don't need a main.py or anything. Harness, agent core harness will take care of the orchestration and everything for you. So we are going to build another agent called as order research specialist, and it helps customers to investigate any order issues or checks warranties and produces any detailed analysis reports. It will also be thorough and provide structured summaries. So we are going to do order as research specialist agent using agent core harness. So this is all we are going to write here. Let me minimize this application. And now we have a new application called as order research agent. And harness.json that we have here is what is going to be our main configuration file for this agent. We can connect this agent with the existing gateway itself. That way, the warranty and then the policies that we have, or the Lambda functions that we connected, refund and warranty Lambda functions we connected, we can reuse pretty much all of that without any problems. So, you can connect the harness to the same gateway, so it inherits the same governance and same tools. In the runtime agent, you are using custom JWT to connect to it. The zero code harness has no inbound user token or anything, so it's not connected to Cognito or anything. It uses machine to machine credentials. You can configure a gateway outbound both. Um, um, if you skip this step, it's gonna default everything to AWS IAM. So I would not recommend to do that. Let's go ahead and make sure that we configure Cognito for this one. So you can look at this AWS CLI commands. They are simple CLI commands. So let's go ahead and set up that outbound OAuth. And let's create that outbound OAuth credential. Add that. So if you go to the agent core JSON, now under your gateway, we added a credential called gateway egress auth for the outbound auth. Yeah, so it's under credentials. It's in the credentials section now. That's where this got added to. All right, and then add the gateway tool with OAuth outbound auth. So let's go ahead and add that tool to the harness. So harness currently has nothing here, or it just only has this information. We are now going to wire the existing gateway to the harness. Okay, once that is completed, in the harness.json, you should see we now have the gateway added successfully. Let's go ahead and deploy this agent, the harness agent, to our agent core. Okay, that's successful now. Let's go ahead and test the agent. Meanwhile, if you want, under the agents, now you see a order research specialist agent along with the customer support agent. And when you go to the gateways, you are still having only one gateway. So we have connected the existing gateway to this one, or under harness section, you can see this one. There you go. So that's how we got a different agent now. Let's invoke this one. What we are doing is we are generating a comparison report. So if you see here, we are comparing the warranty for product 001 and product 003, and we are generating a comparison report. It's an order research specialist agent. So when we want to look at how that report is going to be and all, we'll be executing exec command with harness flag here, which will actually take us into the shell of that particular agent. We'll have the shell access to that agent. We'll go there and we'll be able to read that report that it will generate. Okay, so we have the report ready. Let's go ahead and execute that. So this is the summary comparison report. So between product 1 and 3, how is the warranty duty? How are the things? What is the coverage? What is missing? What are the recommendations like that? So the harness maintains a real file system per session. So files created in one invocation are available in the next. So then the agent can iteratively build the documents, data sets, or code across things. So for example, in this one, that way it will not lose the context. So basically, session IDs and everything, the similar examples that you have seen with the actual agent that we deployed, this one uses files in order to maintain that context and everything. So for example, in this session, we are generating a report we are going to add a recommendation for each expired product. Then we are going to again look at that report and see if that recommendation has been added or not. So let's go here. And so earlier session, we read the file. In this session, we are using that same file and we are adding a recommendation to it, whereas a new section has been added. So because it uses the file, we are able to, file system, we are able to access that previous file and able to update the context and everything here. Sometimes if you want to use a different model, instead of using high-end models, if you want to use low-end models or cheaper models for something like here, summarize the warranty report in 3 bullet points or something, you can try to do that. In this case, we are using Nova model, which is cheaper than plot models. And yeah, that will still work. You can always specify your model ID and control like that. And since we use the same gateway, the governance also got inherited from that gateway. And that's why if you ask to process a refund without specifying the word defective or anything, remember we had that policy, the agent should not do that because it has inherited the gateway, the policy, and everything. See, it said the refund was denied because of the policy enforcement issue. That's how you can reuse existing MCPs and everything. If you want to add human in the loop with inline functions, so how inline function works, meaning like inline functions pause for the agent, return the control to the caller, and once the human provides approvals or any external API calls or any other logic that needs to be executed, that will be completed. And again, the harness will take the control. So for example, agent reasons and decides to call the inline function. The harness streams the response and your code will receive the tool call. Your code executes the logic, whether it is a human prompt or a call API or anything. Your code sends the result back to the harness. The assistant tool uses the user tools. Everything will be echoed. Then agent will resume its reasoning based on all the input that is provided. So let's add an inline function. We are going to say request manager approval for a refund that exceeds the automated limit. Returns approved or denied with the approver name. So let's go ahead and have a manager decide if the refund is possible or not. So we are going to add that inline function and going to redeploy the agent now. Meanwhile, we are going to create a human in the loop testing script. This is a Boto3 script which uses invoke harness API that will help with the interaction with the agent. So let's go ahead and create that file here. Why do we need a Boto3? That was explained here clearly. You can look at that one. There you go. The Python file has been updated. And let's open that Python file and write all of this code. And let's save that. Meanwhile, the deployment here is completed, which is great. So let's go ahead and test the harness agent. Let me clear this for readability and let's test it. So it tried to process the $200 refund that was denied by the policy. So it escalated for the manager to approve. Manager escalation also denied because manager did not give yes here. If you want to do the same thing again by giving yes, let's see. So it asked me for permission here and I said yes. So the manager has escalated it, so it has approved the result. The final result is approved and etc. So that's how you can incorporate this one. So you can understand the architecture of how that works and everything over here. You can look at the code over here. If you want to understand how the flow went, read this and it shows exactly what we have performed. With that, we have completed the harness functionality. We looked into the harness functionality and everything. If you want, we can do this additional advanced harness features like session storage. So the file exists only if for the lifetime of a session. So if you need artifacts to survive, to stop, resume cycles and everything, you can create a session storage. So we got a persistent report agent. So it's going to write all the reports to the storage. So it's going to put everything over here. You can deploy an agent using container to the public image. You are a development assistant with access to Git and like that. And you can do the public ECR if you want. Custom container image kind of situation. You can also extend the harness agent's knowledge by using Anthropic skills here from this Git repository. You can specify that AgentCore add skill and you should be able to see that one. So under research agent, we can go ahead and add those skills for the research agent. So it can use some of those skills. So if you go to this one and go to the harness.json, you should see that we now added the skills. You can deploy it and test it if you want. So we can go ahead and deploy this. We are giving it Excel skills. So we can say that to write an Excel report by summarizing everything, and we should be able to look into that Excel report. Okay, let's try to ask it to use the Excel skill. While that is in progress, let's go to the last section of the lab or the workshop. It is optimizing the agent quality. So earlier in the lab 5, when we evaluated the quality of the agent, we set up like continuous evaluation. We were trying to learn what is the success rate and all those things. Great. Now we identified that your agent is not doing enough performance. It's not giving correct answers, and it is not to the level where you want your success rate to be. You can rewrite the system prompt, you can sharpen the tools, you can, do all of that by hand. You can also use something called as agent core optimization that closes that gap. It turns the real traces and everything into a more AI generated improvements, concrete AI generated improvements. So it will generate a recommendation, package a config bundle, it will validate with A/B test, like it will split the traffic between A and B versions of the agent, and then it will promote the winner and it will repeat the steps. So we are going to use that. We are going to use the existing labs which we completed and see. So it generated an Excel report, as you can see. Perfect. So that completes the previous lab. Let's go ahead and start on this Agent Core Optimization lab. Okay. So let's do Agent Core update because this is a very latest functionality. So we need to make sure the CLI has all the required commands and we have to be at the version above 1.8 for this particular API calls to happen and everything. So go to the customer support agent, go to the Tom, and let's make sure that, yeah, we are above 1.8. So that's great. So we are updated and we are all good. Now, let's go to, let's make sure we have the valid Cognito token still. And let's generate some traffic. So here earlier it is asking us to go to the transaction search in the CloudWatch. So, if you have completed all the prerequisites and everything, you should see that. So you can go to the CloudWatch, go to application signals, and then go to transaction search. So this is what they are talking about. All right, let's go back to the lab. We generated some traffic and everything. We need to wait 2 to 5 minutes for the CloudWatch to ingest the telemetry and everything. But let's start also. We have some evaluations previously, right? We can now have Agent Core analyze the traces and propose a better system prompt. You pass your current system prompt, what you were using, and then it can use that as the baseline. And the target evaluator will look into it and for better goal success rate and using the quality monitor that we have and everything, it will optimize and help us give a better prompt to do what we can do here. So let's take that one and run the recommendation. So the recommendations usually take longer time here. So we will have to wait for a few minutes. And whatever the prompt that it will give, the better prompt it will give for us, That prompt, we will save it in a variable, in an environment variable, and we will use it in the A/B testing. Like I said, the recommendations will take some time, so you will have to be patient a little bit here. Once that prompt has been saved, the recommended prompt has been saved, you can also not only optimize the prompts, you can also see if the agent is picking wrong tools. So right now, agent has multiple tools like warranty, refund, looking up product descriptions, looking up refund policies, all those things. So there are different tools we are using, and you want to make sure the agent is always picking the right tool, and that's how you get the right answers. So you can pass your current tool names, descriptions, and everything, and update your descriptions properly for your tool so that the agent can automatically use the right tool for your purpose. So you can also optimize that part, not just the prompt part. So we are going to package all of that. Other thing is, whatever recommendations that we get, they are only hypothesis. We do not know if that will really improve the quality of the agent. What if, your LLM has given something else, or it understood something else and you got different answers? So before shipping it, we will test it on live traffic by using A/B testing, the same canary model we do with DevOps practices, and see if those recommendations are really giving what we are looking for. And between the existing agent prompt and everything versus the new recommended prompt, which has the better results, we are going to promote that as the winner. That's how we are going to improve our agent quality. Okay, finally we got the recommended prompt. So this is the prompt that it is asking us to use. Let's save this prompt so we can use it in the next testing. So it changed the prompt to this way. All right. Let's go ahead and get a good recommendation for our tools as well, tools descriptions as well, so that the agent can make sure that it is giving. Again, since this is AI based recommendation, it will take a little longer. Please be patient. So how are we going to do the A/B testing? So the recommendation is a hypothesis. So before you route all your customers to the new prompt, you want the evidence that it's actually better on live traffic, right? So that's what A/B testing gives. So the gateway splits the sessions between the control. Control is our current prompt, and the treatment. Treatment is the recommended prompt. And online evaluation scores both of them, the evaluation that we have, and the service reports the statistical significance. So A/B traffic is split at the gateway, the agent core gateway. So the gateway must invoke at runtime through an HTTP runtime target. So you logged the customer support to the custom JWT. So rather than weakening our production, what we'll do is we'll create a dedicated lightweight A/B runtime, customer support A/B runtime, that keeps the default IAM authorizer instead of using the whole JWT and making everything difficult, the testing and all. We are going to create a lightweight environment. It's going to use IAM instead of your JWT, and it's still secure and everything, but it's going to be much faster. And also, we are not going to create any memory or anything as such, so that we are going to keep it very lightweight. And once that is done, we are gonna replace the generated whatever the main file we will get for that agent. We are going to replace it with this code, which is going to be very close to the production, our current production agent, and we'll deploy that agent. Perfect. We got all the recommendations for all the tools now. Great. So we'll just go ahead and create the runtime to deploy a lightweight agent that will help us with the customer A/B, customer support A/B. So now we have a customer support A/B agent. All right. So in the main.py of that agent, we are going to replace everything, the default things that come with it, and add our agent related thing. But this will not have any memory or anything as such. It's a very lightweight. Its main purpose is to validate the responses of the application. So let's go ahead and deploy this agent. Next, we are going to create something called as configuration bundle. The configuration bundle is a versioned immutable snapshot of the agent configuration. So the current configuration, so the control, remember control is our current prompt. Treatment is the recommended prompt. We are going to create the config bundle for both of them. That way we can apply that configuration, meaning that prompts while we are testing everything. Okay. That is deployed. Now let's go ahead and create the config bundles for both control and the treatment. The name of the config bundles also, you can see that we have it as control and treatment. Now let's create a separate evaluator called as AB quality monitor for this particular AB evaluations. Let's deploy all of this again to the agent. Since we are deploying multiple components, the deployment is taking longer than expected. But once the deployment is done, as you can see here, we will have two agents deployed. One is the support agent and the AB agent. We will have a shared memory that is deployed. We have an egress OAuth deployed. We have a gateway that is deployed with two targets. Remember, the two Lambda functions are the targets. We have two evaluation configurations. One is for the quality monitor that has three evaluators. Then we have this AB quality monitor, which we will deploy now, that has 100% sampling and one evaluator. We have two config bundles. One is the support control and the support treatment. And the support control is the old prompt and the old or current prompt, and the support treatment is the new recommended prompt. And then we have a harness. We have a harness agent that we have deployed earlier. So this is all the summary of everything you have been doing so far in the lab. So let's go ahead and run the agent code status and see it all matches everything. We also have the policy engines. We have everything deployed here. So now let's run the A/B test. We will do 80-20 test, meaning 80% goes to the current prompt, 20% of traffic will go to the new prompt. And both A variants will run on the customer support AB agent. We'll be using, so if you see here, we'll be using the runtime customer support AB. We'll be using the support control bundle and support treatment bundle. We'll use the AB quality monitor as the evaluator. And the weight is going to be on control, it's going to be 80, which is current prompt, and treatment is going to be 20, which is the new prompt. All right, let's go ahead and kick that off. So one of the problems is the SEDAR policies are in force mode. So they may block the AB targets or the requests because of missing any of that thing. So what we will do is there is a mode called as log only mode. We will use that log only mode, and we will not make that policies interfere with the traffic. Okay. So let's go ahead and make sure that that has been updated. The policies only become log only mode. What we are doing now is we are getting the test ID and the invocation URL and everything for that one. Now let's go ahead and do a load generation script. And what it'll do is it'll generate traffic. A couple of prompts you see here continuously. These prompts will be going back and forth, and the variables and everything, the token and everything is baked into the variables in the load generation. And we are going to sequence these prompts again and again. That way, we will have enough traffic to do the evaluation. So you see here, request one, what's the price? Okay, I think I made a mistake because I keep getting that. I don't have a target. Yes, I think I missed this gateway target. Okay, let's see. think that's my mistake. Yeah, now. I'll have to redeploy the agent. My bad. Okay, now it should be good. Let's again run the load generator. There you go. Now we are getting the responses. So this load generator, while it is continuing here, let's do one thing. Let's get the A/B test ID and the invocation URL in a different session. Let's see. I hope it gives me the A/B test ID. Yes, I got the A/B test ID. Now, what I'm going to do is I'm going to poll, look into that JSON of the request. So you can see this is how I got the JSON. It should look very similar to like this. So we need to see if the is significant is true. So a winning JSON output should look very similar to this, and the is significant has to be true, and the p-value has to be less than 0.05. That does means that the confidence is good and we are great. And then you can go and update your agent.py, or you can, sorry, main.py. You can update the system prompt either in the main.py or in the production config bundle to this prompt until you get this in significant is true and the p-value is less than 0.05. Uh, that's how you will be successfully able to test everything. And that's how we have completed the final lab. And you can see that what you have built is you did an agent prototype with local tools. You created a persistent memory across sessions. You centralized all the tools via gateway. You added security, observability, and session management. You made sure it has continuous quality monitoring. You have a customer facing chat interface. You have fine grained governance with SEDAR policies. You have zero code agents with harness. And then you have data driven optimization with recommendations and A B testing possibility. So, in other words, over the course of this workshop, you went from zero to a production ready customer support agent using AgentCore CLI. You scaffolded the project, you had local tools and an MCP integration. You added persistent memory so the agent remembers the facts and conversation summaries. You MCPified the existing Lambda functions and added Agent Core Gateway so you can make the calls. You secured the runtime and the gateway with Cognito JWT authentication, and you explored session management and observability. And then you configured continuous quality monitoring with built-in evaluators. You built a web agent chat interface that combines everything. So far, these are all the agent code services you have used for that one. Then you added fine-grained governance with SEDAR policies, which is using agent code policy. You built a zero code agent that only uses CLI configuration, and you can explore the shell access and everything, which is agent code harness. And last but not least, you have used generative AI driven system prompt and tool description recommendations from production traces, packaged them as configuration bundles, and you validated and improved your prompt by running A/B traffic, 80/20 traffic on your current and new prompt, and you promoted the winner, which is the agent core optimization. So simply put, the Agent Core CLI has abstracted the infrastructure complexity. It's a great framework and it's model agnostic. The memory is what separates a demo from a product. The run gateway turns existing APIs into usable tools for yourself. Security is not a configuration change, it's just a configuration change. You don't have to rewrite anything or anything as such. Governance is totally outside the agent. That means you don't have to modify anything. And observability and evaluation come for free. And last but not least, you can do optimization based on your monitoring.